let's take a look at this example. This time we're supposed to determine the magnitude and the direction of I3. Please notice that this is nothing else, just series parallel circuit with the current source. So what I would do first, I would find the total resistance of these two resistances, right? So I would say that this is R1, 2, which is equal R1 plus R2, which is equal, R1 is equal 1 kilo ohm plus 2 kilo ohms is equal 3 kilo ohms. And I can redraw this circuit, and my circuit is going to look like this. I can draw something like that. So this is my R1, 2. This is my R3, and this is my R4. Okay, as you can see, we have 3 resistors in parallel. So what I would do first, I would find the total resistance, because I want to use the current divider formula. So we have R total is equal 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. And this is equal 1 divided by, open parenthesis, 1 over, mistake, this is R1, 2, this is R3, and this is my R4. Okay, my small correction. So R1, 2 is equal 3 kilo ohms plus R3, which is equal 6 kilo ohms plus 1 over 4 kilo ohms. This is equal 1 divided by, open parenthesis, 1 divided by 3 exponent 3 plus 1 divided by 6 exponent 3 plus 1 divided by 4 exponent 3. This is equal 1.33 kilo ohms. Okay, so this is the total resistance of my circuit. Next, I'm supposed to find I3. Okay, I'm supposed to find the value of the current I3. So I'm going to use the current divider formula. I'm going to write I3 is equal I source R total over R3. So this is equal I source 12 milliamps times R total, which is equal 1.33 kilo ohms over 6 kilo ohms. This is equal 12 exponent 3 negative times 1.33 exponent 3 divided by 6 exponent 3. This is equal 2.66 milliamps. 2.66 milliamps. And if someone is going to ask you in which direction current is going to flow, please notice that this current source is going to push the current up. Okay, so the current is going to go this way, is going to split. Okay, over here is going to also split over here, and is going to split over here. So the current I3 is going to go from top to the bottom. It's going to go this way. Okay, because this is like a water. Okay, imagine this is water flowing, so the water is going to go like this. Okay, so the current is going to go from the top to the bottom as well in this case, because the current is pushed up, and after that it has to go to the ground. That's why the current is going to go from the top to the bottom. So this is my I3 and the direction. Now next we're supposed to find V1. Please notice that these resistors are in parallel. So if you want to find V1, okay, V1, we're supposed to find, let's say, first, let's say V4. Okay, why V4? Because it's going to be easier for us to do it. So if V4 is equal to V3, okay, and this is also equal to V12, okay, voltage across these two resistors, okay, from this point to this point. Okay, this is not the voltage across the individual resistor, this is voltage across these two resistors. So this is going to be found by simply using Ohm's law, and I'm going to simply write that this is I3 times R3. Why? Because I know already current which goes through resistor R3. I know the resistance of resistor R3, so I can find the voltage across resistor R3. And this voltage across resistor R3 is going to be equal to the voltage across resistor R4, and is going to be also equal to the voltage across resistor R12. So I3 is equal to 2.66 milliamps times R3, which is equal 6 kiloohms, and this is equal 2.66 exponent 3 negative times 6 exponent 3 equals 15.96 volts. Okay, so this is my voltage V4. I found I3. So if you want to find V1 is the voltage across resistor R1. Please notice that these two resistors are in series. We already found the voltage from this point to this point, right? So voltage at this point is equal 15.96 volts. So if I know voltage across my current source and voltage across these two resistors, right, which are in series, I can use voltage divider formula to find the voltage across resistor R1. Okay, so I'm going to simply write that V1 is equal V12 times R1 over R12. Why I'm using voltage divider formula? I'm using it because students must practice it. Of course, you can use Ohm's law, but very often you're supposed to use voltage divider formula. That's why I keep forcing you to use voltage divider formula, because sometimes you don't have to find the current and you can find the voltage. So V12 we found is equal 15.96 volts. R1 is equal 1 kiloohm. R12 is equal 3 kiloohms. Okay, we found it. This is equal 3 kiloohms because R1 plus R2 is equal 3 kiloohms. So this is equal 15.96 times 1 exponent 3 divided by 3 exponent 3. This is equal 5.32 volts. 5.32 volts. So we found V1. Next we're supposed to find the power P2. So in order to find P2, we're supposed to have at least voltage or current which goes through resistor R2. You're supposed to realize that I1 is equal to I2, and you can find this by dividing V1 over R1. Again, this time we are going to practice Ohm's law. V1 we found this is equal 5.32 5.32 volts over R1, which is equal 1 kilo ohm. 5.32 volts divided by 1 kilo ohm is equal 5.32 milliamps. Okay, so if you want to find P2, P2 is equal I2 to the second power times R2. So I have 5.32 milliamps raised to the second power times R2, which is equal 2 kilo ohms. This is equal 5.32 exponent 3 negative to the second power times 2 exponent 3 equals 56.6 milliwatts. Again, let's take a look what the problem was asking us for. So we found I3, we found V1, we found V4, we found P2, so we can say that the problem is solved.